recording. Here we go. I'd like to welcome everyone to the Data Architecture Virtual Chapter today. My name is Rob, and if you want to contact me, my contact information is on the screen here. Today we have Eric Peterson. He's given a talk on in-memory tables with SQL Server, and I'm really excited about hearing this presentation personally, because this is something I haven't had time to look at very much. So going to the next page, let's see. So I got this week, or maybe earlier last week, a discount code to Summit. So if you're going to Summit, here's the code, and it'll save you some money. They didn't put on my email how much it is, but I know it's some money, and use it. And as a side note, if enough people use this code, we can actually give away, I think we can, we did last year, we gave away two trips, I mean not trips, but two of the Summit, conference to two lucky people, so they could go for the 3-day event. It was really cool, so we may be able to do that this year. I'll find out more and I'll pass that on to y'all. So PASS is going to have elections, and they wanted me to share this with you. Please log on and update, the MyPass profile. It says here about June 1st, and you can vote on the board of directors, I think it is. If you go in there and, update your information, they'll probably be sending you an email or somehow get in touch with you so you can do some voting on the next board people. Of course, the Business Analytics Conference is coming up, and it's going to be May 2nd through the 4th in San Jose. So if you want to register, you can go to the web link right there at passbaconference.com and register, and you can, get to go. Here's some upcoming SQL Saturdays. You can see if, let's see, Phoenix or Ottawa, or it's a really cool thing to do, go to these free training, and when it's here in Baton Rouge, or if I get opportunities, I go out. I've been to different ones in my life, and they've always seemed to be, I learned something great. And so here are the upcoming ones. I would recommend, if you have time, sign up for one, and it's at the www.sqlsaturday.com address. Let's see. Okay, so we're ready to start. Oh, I have one other thing to say. We do have 2 gift cards to give away today, and I'll just email them out after the sometime later today. So I will pick some winners, and someone will be lucky enough to get a gift card. So I'm gonna change over to Eric right now. Eric.
I'm here, and let's
just making sure you're getting
all right, so we've got how's that?
I can see it. Thank you.
Excellent, excellent. Hello, my name's Eric Peterson. I'm going to be presenting on in-memory tables and in-memory stored procedures. Give an overview, but a little more than an overview. I'm actually going to give some examples of how things work. As we go through the presentation, don't hesitate to ask a question. I don't know if the attendees can speak right up, or if they need to put a question into the little box over there.
Yeah, so if you have a question, just stick it in the question box, and I'll help Eric out, and we'll get your question.
Great. So let's get started here. All right. Like I said, don't wait to ask questions. And the agenda, I want to kind of define what in-memory is with SQL Server, how to set your databases up. I'm going to give examples of that. Table setup, indexes, stored procedures, cover some metrics, and then 2016 is coming out sometime soon, and they've enhanced this quite a bit. So I'm just going to briefly cover what they do there, and we'll have time for questions at the end. And then remember to stay on, because we're going to have some gift cards to give away as well. All right, in-memory. SQL Server 2014, the Hackathon engine. Hackathon, Greek for 100. The original goal was that they wanted to make this, particularly with the in-memory things, up to 100 times faster than SQL Server. With 2014, they were not able to achieve that. And we'll go through that in a little bit. But in-memory tables are defined within the database, but instead of being assigned to disk, they're assigned to the RAM of your server. The really neat thing about this is they've re-architected the tables, and I'll go into that in quite a bit of detail, but it contains indexes that are lock and latch free. So if you're doing OLTP type of processing with lots of updates and reads at the same time, you don't have blocks anymore. And you don't have locks that you have to worry about, and that is really hot if you're going through and doing it. Memory in the SQL on the servers. I remember a time when disks were $1 million a terabyte, and memory was easily more than that. Now you can get gigabytes upon gigabytes of memory and put them on these servers, and it's inexpensive in comparison and is fast. Now, I'll put a caveat on that fast, is the disks have gotten a lot faster too. So depending on what you do, you may or may not get an advantage out of in-memory tables. I'll go through the information on all of that. But the real bang for the buck is in-memory tables and accessing that data with in-memory stored procedures. Absolutely, hands down, that is where you are going to get your biggest bang for the buck, because the new stored procedures are compiled at a machine code level that can be executed by the CPUs, and they just scream. And this is really where they were shooting for with that 10 times performance improvement. 2016, they are saying they're gaining up to 35 times performance improvement. Now, 10 times doesn't get your attention. 2016 and 35 times definitely will. Here's the downside, is it's available in SQL Server 2014 and greater, Enterprise Edition only. So you've got to have the Enterprise Edition to take use of this feature. Internals, all right, and I'm not going to go through all of the internals. There's a lot more information on this than I could possibly cover within a half hour to an hour here. But the highlights of this are that databases now have a new file group. This file group can only be removed by dropping the database, and it shows up differently within your server properties. Tables can be loaded when SQL Server starts. They're very fast to process, but, and here's the catch, it may increase recovery time. There's also different types of tables out there that will be empty upon start of the SQL Server. For certain things like logs, that's great. Other things, you're going to have to take time to reload it. Internally, there's a new row format. There's no data pages anymore, and every row is versioned. They actually have a date stamp on there. I'll show you the actual underlying architecture with this. So rows are not really replaced or updated like they were before. It's actually going to insert a new row and then turn off the timestamp for the existing row. So this optimistic concurrency offers no locks and is faster. There's new index formats. There's range indexes and hash indexes. I'll go into great details on those as well. Database setup. I put in here the alter because most of us have existing systems, and you're going to want to alter your database to add a file group for in-memory. Really, if you're doing it, here's your SQL, alter database, in-memory testing, add file group. In-memory file group contains memory optimized data, and that's really where the magic happens. You've got to put that in there. It's just going to be a regular file group. And then, again, you have to add a file to store up into memory. So you're adding a new file. You also have to specify a disk location. All right, and this is for the persistence of your in-memory tables. so that after recovery and after the server is shut down, and when the server is shut down, your memory is cleared out. This is where the file gets stored that's brought back up into memory. So you can't go disk-free within memory tables. You still have to have disk available, and it has to be disk that can support the transaction throughput. Now, before I go into the details of that, I'm actually going to show you a couple of things here. As we go through this, I have examples, and at the end of the presentation, I've got an email address here. You can send me an email. But really, what I want to do is show you this and go through the properties. I've already altered the database to add the information here, and let's actually go look at that. So we have files. All right, and if you notice where the file is, it's in the in-memory file group. Where does that file group reside? Well, if you look up here, I don't have a file group for in-memory. What they've done is they've added a new section down here called Memory Optimized Data. And if you want to go in and alter your system this way, you just add your file group and do it here. It's just like doing it everywhere else, but as with SQL Server, you can do this in many ways. You can do it when it's defined, you can alter it, or you can do something here. So let's go back to the presentation. All right, in-memory table features. Now, after you set up your database, you want to set up your tables. And there are a number of restrictions and things you have to do. You cannot move everything and anything to the SQL Server in memory. What you want to do is you need to have a non-clustered primary key. And you've got to specify non-clustered in that, or it doesn't work. If you try using a clustered indexes, you do get an error message. You're only allowed one unique index. Your row length can be a max of 8060, and it's enforced in creation, not like on a regular table where you can define your row length to be longer, but you don't get an error message until you actually go over. Well, this it does. It actually takes the full maximum amount of each column and puts it out there, and if you are over the 8060 barrier, it is not going to work. 2014 in particular, you cannot alter in-memory tables. All right, and this for me was a real problem when it first came out. I'll tell you in advance here, 2016 they changed that. But you really, if you've got something in production, you want to alter it. You want to add a column, you want to change something. Well, you can't do that with 2016. But this includes your indexes as well. Hey, you're seeing someone's accessing it on one thing in there, and you want to add an index. Oh, hold on. You can't do that with SQL Server in-memory tables. Indexes have to be created at table creation time. Here's another gotcha. You've got to have your collation to Latin 1 General 100 Bin 2. Especially if you want to search those things with stored procs or have an index on them. You can do it on a row-by-row, or I shouldn't say row-by-row, column-by-column basis. Or you can define your whole database as Latin 1 General Bin 2. But remember, this is going to make it case-sensitive, which is not the default for SQL Server. Lots and lots of features are not supported with the tables as well. Foreign keys, unique check triggers, truncate, DBCC check table, data compression, replication, column store, computed columns, partitioning, updates of the primary key, create index after the table's created. It just has to be done as part of the create statement. Alter table, if you want to go to Microsoft and you look at the full list, it is out there, and it is pages long. Really can't just show everything here. What I really wanted to show you is, and some of the reason for some of these limitations are because they've altered the internal architecture. Now, with older systems, you basically had a row ID, and it had some length, and whether it was variable character, and then you had the rest of your data. Well, they've changed that a little bit, and they've really put a lot of logic into your row header. Your row header now contains a begin timestamp and an end timestamp. It contains a statement ID. It contains a link to all of your indexes and pointers to the indexes. So this is why your indexes need to be defined at the same time as the table, because it's all part of every row that's out there. You can't change this once it's in place. And it's real important that you know that these are slightly different animals, but if it works for your environment, particularly OLTP, and you can use the stored procedures, you're going to get a big payoff from it. All right. Your payload layout or your data, normally as you say your columns, most of your data types are supported. So you've got bits, all of your integer types, all money, all floating types, numeric and decimal types. The storage is a little bit different. So if you're actually calculating your actual length on there, the storage is a little bit different. It brings it in either 8 or 16 bytes. Date time, small date time 2, again, storage changes to the way it was before. A lot of your string types, character, varchar, sysname, bin, nchar, nvarchar, unique identifiers, those are all supported. So the things that you do most of the time, your usual data is going to be going into this. Things like XML are not. Next, and this is the most complicated part of the system here, is there are 3 table types that they talk about. And all of the documentation talks about 3 table types. But to be honest, there's really only 2 table types. And usage creates a 3rd table types. And that's not documented anywhere. You can look even in Microsoft's documentation. You will not find that anywhere except for this presentation. All right, first of all, there's a durable memory optimized table. And when you create an in-memory table, it is fully durable by default. All of your transactions are written to the log just like you have anything else. Your data is reloaded when SQL Server starts. Again, you need to look at this. If you've got 100,000 rows, well, it's going to load up fairly quickly. If you have 100 billion rows, well, then you're going to have to wait, and that may increase your time. In fact, it'll definitely increase your time if you're using clustering and you want to fail over and you want it to be real quick. Well, you're going to need to figure out something to do for your in-memory tables that are really huge, because it may not work. Non-durable memory optimized tables. Now, these tables are schema only. And when you start up SQL Server, it puts the schema out there, but there's nothing in them. There's also, they're not logged and written to disk. So there's really no I/O because there's no logging. It just happens in memory. Now, here's the downside. There's no recovery of any changes. So it's really empty upon restart. Like I said, it's a schema table. Now, why would you want to use that? Well, let's say you've got a web session and you're keeping track of your that session state. When the server goes down and it comes back up, well, someone's going to have to hit enter again to show you where you are in that chain. It's not going to be there. But it's going to be really, really fast for your online users because we're not logging that information. And you may or may not want to log that information. Now, in-memory OLTP is the 3rd type of table that a lot of the documentation talks about. But really, a in-memory OLTP table is a durable table where the transaction write is delayed. And you only can do that within a stored procedure. Okay. Oh, and you also have to set your delayed durability on, saying it's allowed. And then within the stored procedure, you have to do it as well. All right? So now let's get down to actually how we do this. All right?
Hey,
You create your table.
Do you want to take one question here?
Sure.
Okay, because it's kind of relating to your slide, your previous slide. And the
All right.
question is relevant because they're asking, can tables be set up to load when they're first query instead of loading up on startup?
The answer is no.
Okay.
Now, if you have, you could set up a procedure or something, possibly, and I haven't tried this, so it's worth a try. You know, you've got the ability to put in triggers and other types of things, possibly something that, you know, 1 minute after as the server comes up, you actually can load up your server. You could have a job that checks it, you know, do a count. Do it every 5 minutes, so you're not going to prevent your server from coming up. But the, yeah, it's one or the other by default. And there's nothing that's built in that would do it for you. All right, so going down to actually how do you create a durable or OLAP table. You create it just like you would anything else. And here's the magic, is down here in this with area. With memory optimized data equals on, durability equals schema, i.e. the definition of the table, and the data. And that will make it durable. That will actually write logs out to disk and give you the ability to restore that table when it comes up. Okay. Creating a non-durable table, almost identical, but if you look down here at the with part, durability equals schema only, i.e. when the server comes back up, you're going to have a defined table out there, but it's going to be empty. All right, indexes. Again, here's another slightly complicated part. They've got to be created within the create table statement. No unique indexes other than the primary key. Non-clustered indexes only. If you say clustered, it blows up. In-memory indexes are inherently covering. And the reason they are is because of the way they're defined. Do you remember up here when we were talking about this? Look down here in the end. You've got your indexes that specify what's going on and where. All right. In-memory indexes exist only in memory. So the index structures aren't persisted to disk. They'll get rebuilt as you go and you reload the table. Which also means you don't have to defragment them, which means defragmentation doesn't apply. Fill factor doesn't apply either. So, you know, it's a good thing. It's going to save you some time for your system. You can only have up to 8 indexes as you go. So that, again, may be a good thing. For some tables, it's not a good thing because you want to index on more than that. There's 2 types of in-memory optimized indexes. There's a hash index and a non-clustered index. Hash indexes are specifically made for point-in-time lookups, or I should say point by key. And the values should be of a high cardinality. So if you have a sex table where it's male or female, not a good idea to make it a hash index. If you have a table based on zip code, well, there's a good one, because now you've got 10,000 spots that you can put out there. And, you know, if it's zip plus 4, you've got, you know, you've got 1 million spots you can put things in. Non-clustered indexes specifically they work best if you've got a range. So what you want to do is order your data by the order of that range in the scan. And you know, the information comes back according to that order specified within the index creation. Hash index and a new term called buckets. You'll see when you create your table and then you put the index on, index hash with bucket count equals 100. All right, so how do you figure out your bucket count? Well, the bucket should be greater than the cardinality of the values. So go out and do a count asterisk on your thing and then do a distinct count. See what the differences are. Because you're going to want to have a bucket out there for each value, and then that's going to have the pointers to each row. There's also, if you want to check after the fact, I'm pretty old school. I like looking at system tables. And if you go out there and you look at the system sysdm, oops, let me go back over here, sysdm xcp hash index stats, it's going to give you stats on those in-memory things, and it's going to look at the buckets and the bucket counts and what everything is going on within that. Non-clustered indexes, they're often better than the hash index, especially if you don't know the cardinality. Internally, it uses a new structure. It's a BW tree structure, which is a latch-free version of the B tree index. Again, there's no fixed page size, so you don't have to worry about defragmentation. Index pages are never updated. They're just replaced with a new page. And that same thing goes for, you know, it's the same thing with your rows. You don't update, you actually replace. All right? Now, here's a better example of creating tables. Create your table, and this is a hash index here with your bucket count on. Second one is a primary key non-clustered hash with the bucket count of 100. The third one, which has the tables created with a constraint on primary key non-clustered. The index is non-clustered, and here's the key, you know, memory optimized on, durability equals schema and data. So that's going to say that that is created in memory, and your index would be created in memory. If you notice over here, the order, the descending or the ascending, that's the order your data is going to come back. So really, if you want something to come back in descending order, particularly dates, you know, often you want dates to come back with the most current one first. Then you're going to want it to go in descending order. All right, and I can actually show you some examples of this. If you notice over here, my tables, and I've done this presentation a few times, so I've got a couple of different tables here, and I've already run the alters to set up my files. What I'm going to do is I'm actually going to create a new durable table and call this right. And what it will do is it's actually going to create the table. All right, oh, here we go. That's what I get for doing real-time changes to something that's already out there. There we go. So I've got a new table, and it's going to show up just like everything else. Now, I would highly recommend that as you do this, so that you can tell the difference between a table that's on disk and a table that's not on disk, is I actually define, you know, if it's a durable table or if it's a non-durable table. You can do that up front if you want, put a prefix on, or you can put it as part of it. I just put it as, you know, hotel durable. Remember, I work for a travel company, so things I deal with are hotels and currency and travelers and all sorts of that. So you can see kind of the types of data that I usually deal with out here. And as I go and refresh this, you're going to see, okay, here's the new table. Now, if I go up there and actually avoid typing and copy. Okay, it works. Now let's take a look at this. Let's see how long it actually takes to put some data in here. All right. So as you saw, very quickly, I just put in 136,000 rows. Hey, that's great. And you know, that goes right up into memory. It's durable, so it's going to, you know, when I restart the server, it's going to get recreated. Again, here's some other examples. I won't go through and create all of those. But once you do that, you can start going in and looking at the actual timings for them. And I'm going to tell you up front that if I go out here and update my statistics and turn my stats on, you know, how long does it take to retrieve back data? You know, it's pretty much sub-second time frame. Well, if I go out here and look at the same thing, with that, again, it's sub-second time frame. What you will find is that the in-memory tables are at least as good as your disk. Now, I've got some nice EMC storage behind this. Very expensive, great big SAN. I often do not find an advantage when I am querying against a system between in-memory and not in-memory. And that was really a shock when I first took a look at this. I'm expecting, hey, this is going to come back 10 times faster. Well, no, that's not the case. It comes back when you use stored procedures or you've got additional logic out there. That's where you get your biggest bang for the buck. So let's actually go back to the presentation here and look at the in-memory stored procedures. All right, you can notice Dilbert's dancing up there because this is where you can get the 10 times performance improvement. Remember, 2016, 35 times performance improvement, and that is where you and I are going to make our money because we can push things up into memory, and it's going to say, oh, you know, it's got about the same thing. We push it up into memory, and all of a sudden procs are running 10 times faster, 35 times faster. Well, then people are going to be saying, hey, you know, you can dance on your cube in your underwear, and I don't care. It's really good. Now, the really neat thing is that this has native compilation into the SQL Server. It really means that they've compiled this down to the CPU language so that it can be executed, and it is super optimized. All right? Now, here's the downside. You can only access in-memory tables. You can't reference disk tables or views with an in-memory table. So with an in-memory proc, you've got to be accessing in-memory data only. If you want to do a join out to that, because joins aren't allowed. If you want to do other types of things, there's a list of restrictions here that you can't do. Cursors, subqueries, the values of like, in, or, the not operator, but you can use not equals instead of not. Now, why one works and the other doesn't work, I don't know. If anyone's from Microsoft, maybe they can answer that. Outer joins, unions, intersects, go-to statements, temporary tables, compute, multi-row, update, insert, delete, or select in twos, case statements, all sorts of things you can't do within the stored procedure that, you know, the pointy-haired boss there is going to say, hey, I want this, and you're going to point back and say you can't. At the end of the presentation, I'm going to go over 2016. They've really enhanced this. 2016 is a hell of a release, and they've really put some work into a lot of these things. Again, if you want the stored procedure to compare a column, it has to have a bin2 collation. All right, if you can do it on just the one column, you can do it on the database, you can do it on everything. Also, when you create your stored procedure, and this is where you get, they say there's 3 types of tables, but it's really 2 types of tables plus a stored procedure that gives you a third option, where it's your OLTP is defined here because you say within that stored procedure, delayed durability equals on. All right, let's look at this. Several new things within creating a stored procedure here. All right, and I've got these in an example that I can send out to you if anyone wants to look at it. Create stored procedure, you're going to get a date and a code. You know, the top stuff, okay, that's all normal. But here we go. Begin atomic with delayed durability equals on. Yes, that's an OLTP type of stored procedure. Transactions, isolation level snapshot, language is this. Everything in there is hard-coded at compilation time. Now, once it goes out there, you cannot alter the stored procedure. Again, something in 2014 that wasn't good. Select, you know, and this is just a simple select statement to pull back some things. So, I mean, it's real simple of how you do that. Let's actually go back over. Let's actually go to the examples. We'll go in here and again, you may, as you want to go in, there's nothing that tells you if you just go out here and you list things up. So let's look at all the stored procedures. There's nothing that tells you whether the stored procedure is an in-memory table. So what you have to do is, you know, usually what I do is I'll say it's an in-memory or somehow, you know, memory stored procedure to flag it up as a, you know, in-memory stored procedure. So we'll create this one real quick here, just like everything else. And then we'll go over here, create the new in-memory one. Again, it just goes right in. Again, you know, we're just telling it, you know, what it'll be, what it does. Transaction isolation level. If you notice, I did not put in the code that says delayed durability equals on, which means this is just a durable table, not a OLTP table. All right, and the only way you can go out there and do this is by changing the in-memory is by dropping it. If I go out there and execute, I'll just execute these 2 procs side by side. All right. If you look, they basically came back about the same amount of time. You don't, like I said, with in-memory tables, you don't always get a benefit. But if you're doing something where you normally would be blocked, or there's lots of inserts going on, or someone locks a page, you're going to then, that's where the things where you really start to get it. If you have a lot of logic in your stored procedure because it's being executed at the machine code level, you're going to get a huge, huge performance increase as you go through. To do this, I ran some comparisons here, looking at it from a millisecond thing. And I really wanted to do this where it was executing for minutes or hours so that I could really see the difference. And sure enough, you really could see the difference when you're doing inserts and updates at that level. Just regular T-SQL with an in-memory table. Started out a T-SQL with in-memory schema only. If you notice, there's a difference there between the amount of time. What is that difference? Well, that difference is roughly 50%. And why is it 50%? Because you're not having to do the secondary log write. All right? Now, you go after that same thing with a native stored procedure in memory. Again, look at, is there a huge difference? Not as much. But if you're doing it with in-memory schema only, you're getting down there to a considerable amount. Roughly, according to this, we're roughly 1/3 of where we were before. So that's something. Now, if you've got something that executes once, it may not be huge. If you have something that executes 100 times, 1,000,000 times, 100,000 times, well, then you're definitely going to see some improvement as it goes through. 2016. Lots of things that I thought were Achilles heels for in-memory stuff has changed. I've highlighted a couple of them here: alter procedure, alter table, outer joins, unions, distinct, exists, etc. All of those things. Indexes. You've got all this stuff that you couldn't do before is now supported. Indexes on nullable columns. That's something I didn't bring up before. Now you can have an index on those columns. Non-bin2 collation in index key columns. Before, like I said, I kept pointing out you had to do this. I haven't tested this out in 2016 yet, but I bet it will be supported. Foreign keys, check constraints, etc., as it goes through. I would have to make sure about this, wondering if a check constraint can point to a non-in-memory table. I'm not sure if that works or not. Something, again, that we all have to test. And lots of SQL Server Management Studio designers now supported. Wally up here says, wow, with all the stuff they've done with 2016. And this is just for in-memory enhancements. They have 10 or 15 features, all of which I could talk about for a half hour to an hour. If anyone wants the scripts that I have out here that show you how to create, and these should be fairly easy to do, let me know. I'll even, before I send it out, what I'll do is I'll actually give you, 100 rows of currency and 100 rows of hotel data. I'll actually put that into a stored procedure into this, so you can actually create using exactly these same things. So, as you go through, you can run your own performance metrics, see how things work in your own environment. OLTP. Again, the script is available. All you have to do is send me an email, eric.peterson@bcdtravel.com, and I'll forward it on to you.
We have a few questions if you want to take them now.
Yeah, questions. Let's go through them.
So how does the performance change between the options of durable versus non-durable?
Well, the non-durable, as you can see from the benchmark, you're not doing a log write. So without that log write, it goes faster. And it's almost up to 2 times as fast.
Cool. The next question is, and I think I saw the answer, will foreign keys be supported in-memory tables for SQL Server 2016?
The answer is yes. So yeah, foreign keys over here are supported in 2016.
Next question is, if a database is taken offline, will the in-memory data be cleared? If we bring the database back online, will the data load into memory, or is it like a server restart? Kind of messed the question up, but
that's actually a really good question. I don't know. I assume it's like a restart, because that file group would go offline as well. But yeah, that's something that I'm actually going to test that one, and yeah, see what happens with that. I would really like to find out that answer myself.
Okay. Can an on-disk procedure refer/consume an in-memory table?
No.
Okay. I think you mentioned that earlier. I think I remember you mentioning that. That's a great question. Can you use temp tables or cursors in the memory store procedures?
No.
No. Okay.
Yeah, that one we covered up here. That was definitely on the list. Let's see, indexes, stored procs, cursors, subqueries, temp tables, all on the list.
In 2016, did they make any changes to that?
This was pulled out of the 2016. This actually I didn't type this in. I actually cut and pasted out of the 2016 documentation. I haven't tested that. Again, that would be something really good to test. Very good questions, though.
That's all the questions we have now. Oh wait, here comes another one. How are transactions handled with in-memory tables?
The same way they are within regular tables, except, if it is a schema-only table, you will not, there's no log to write. Now, because there's no log, you've got something that's different. It's in each row. If you have to roll back, then it knows which ones to go back because of the timing of the transaction. So it's a little bit different. Instead of reading the log and backing things out, it actually looks at the table and backs stuff out.
Oh, yeah. Wow, we're getting quite a few. Can we roll back a transaction since there's no log?
Yes, because of the design of the table. Because they have a begin timestamp and an end timestamp, they know when things changed.
Oh, I got you. So it's all in memory.
It's all in memory at that point in time. So they can bring it back.
Well, that's cool.
Yeah. Now remember, durable tables do have a log. Or a log of sorts, I should say.
How are DML operations performed on in-memory tables?
The same way they are with regular tables. We go over to my example here. Let's go look at. We created a table up here. All right, we created a table of currency hash architecture group. So let's all right, so we're going to update the table. Equal to mid-market rate plus let's say we had an error in my currency table, so it's paste. Let's say +3. Where this is equal to AED. All right. So it's just like anything else. You just go in there and you do it. Boom, 609. All right, let's go out here. Let's do. All right, we had questions about this, so let's see what happens. All right, so we're going to create the pardon my dyslexia, I don't see where the error is here.
Do you want to do a begin? I'm not sure in this. Well, that didn't help.
There we go.
Yeah,
Yes.
yeah.
All right, so we're going to begin a transaction. All right, update the tables. Okay. Well, I was wrong about that. All right, we'll have to work on this, actually, how to build it within the transaction itself. It looks like we'd have to use a snapshot definition. Let's see if we get it to work all in one here. Nope. We'll have to work on that and see how we can get it to work. Define the table with the snapshot and get it to go. So, good questions out there.
Here's a great question. I think it's great. I think this is an interesting question. What are the impacts of detaching and attaching? I'm guessing it's the database, but you said processes. So.
Yeah, I assume it's the database too. Well, let's see. I mean, we can take this and since this is my test system, we can actually and in fact, we had another question out here. Let's create one. All right, let's create a table out here that's schema only, and because we had a question about that earlier. What happens when it's all right, so let's actually create one. Good, so we've got a schema-only table. Let's put everything into it. Okay, so there's nothing out there right now. Let's insert into it. Okay, so put in 130,000 rows. Now, if I go out here, let's just try right now taking it offline first.
It may not let you do it if you're have a session open, you know?
You are correct. Yeah, I am probably...
But, you know, demos, you know?
Yeah, I know. So let's go over here and I think the only one that has something open is me. I'm the only one here. Let's connection disconnect. There we go. Great suggestion, right? So we're offline. All right, so let me bring this back online. And I'm assuming that the detach works exactly the same way. There we go. All right, so let's go down to my. All right, so let's look at. We had 100,000 rows in that before. Let's see what we have here now. There. Of course, because I'm in the master database. Oh. Yeah, it's empty. So I would assume with detach, it does exactly the same thing. It does not repopulate the schema-only tables.
That would make sense.
Yeah, those are great questions.
Okay, let's see. I think we got them all. If I miss one, oh wait, got one more. Well, one popped up here. What does clean memory buffer? And then the question just kind of died there. What does clean memory buffer do?
You were reading through the script here. All right. If I go out here and okay. All right. DVCC drop clean buffers. I'm sure that's what you're looking at.
He says yes.
Okay. What that does is it cleans out all of my memory buffers so that when I execute my time, so let me go and execute this. All right, and my messages are going to tell me exactly what we've got here. Set time on, statistics on. Okay, so it's going to tell me everything that goes on with that. All right, so here's my plan. Let me set the turn the show plan off. There we go. So what it does, it just resets all of the statistics. It also flushes my buffers so that the second time I execute a statement, this should go quicker. It actually took longer. That's the fun of this. But it flushes my buffers so that I don't have any times out there, anything that's up in my buffer. And here's an in-memory table, exact same thing. Look at that. All right. You notice this actually took longer to run than the memory table. So like I said, go out there, do it, benchmark, see what works best for you. And in particular, in environments that you do have a lot of inserts coming in at the same time, this thing can really scream. We have a traveler profile system that we're testing with. And, because travelers are traveling all the time, if a incident happens, shooting in Paris, a plane, heaven forbid, goes down, so a hotel fire, the first thing we do is we get notices, and we have a staff that actually goes in there and starts looking to make sure none of our travelers are in any of those situations. If they are, automatically texts will be sent out to their phone, but we need to have real-time updates. So our data warehouse is being updated constantly. We don't have a 24-hour latency period on that. And we often run into blocks from the update process because of that. So for this is really showing us some really great performance, because now we don't run into blocks anymore, and we don't have that issue.
Wow. Well, thank you, Eric.
Anytime.
We're out of time, but we have some questions, and I'm going to forward them off to you, and
all right,
if you don't mind. And do you want to? I mean, I'm not putting you on the spot. I can do this later. Can you see the list of attendees here?
I can.
Do you want to pick two out? I mean, we could just pick two, and we'll email them later and see if they want to. If they don't want to accept it, that's fine. I'll pick some other people. You want to pick two winners?
Okay.
Well, randomly, whatever you want to do.
All right. I'm just going to click my button a few times here. It's probably going to be someone in the middle. And we have a fellow Eric out there, Alec Axelrod.
Okay.
All right. And I'm going to go down two from that. And we have Kenny Neal.
Okay.
Who may have disconnected. And if he is, it's going to go to the next one, which would be Kevin Goffredson.
Okay. Kevin. Got it. Copy. Okay, so what I'll do is I'll email these people. I'll do the first.
It looks like Kenny's still online. So.
Oh, okay.
Whatever that message was out there.
Well, I will shoot an email to the first two, and if one of them cannot accept it, we'll go to the third.
Great.
Thank you for doing that, and it takes my pressure off of me.
All right. Like I said, if you want the scripts, I'm more than happy to pass these on to you. Test them in your environment, see what works best, and happy computing.
All right. Let's see. Oh, one person said he wants it, so Mr. Jackson.
Send me the email.
Sure.
And again, here, I'll pop it back up here. There we go. eric.peterson@bcdtravel.com.
Cool. Oh, well, there's one question here. I'll just ask you really quick. It's a simple question. Can you set a max and min memory limit on your database? Oh, well, actually, your SQL Server. I guess. I don't know. What are the max and minimum memory limits on the SQL Server? Oh, I'm not sure where he's going there. I mean.
Well, I do, because normally when you are dealing with the SQL Server, here, let me go back over here, and we look at the system. You look at the properties, and when you're dealing with files, you're dealing with an initial size. Auto growth is unlimited. So I can limit my log to be, let's say, or whatever. But you've got limited to, so this log is limited to, let's just make, it's 2 gig, right? That's megabytes, or that's 2.
Someone
so
said
you can
2
go up
terabytes.
there and do it. It looks like the in-memory file. Let's see if I can do that. Maximum size you can limit it to. So yes, you can.
Great. Well, thank you again.
Hey, great question.
Everyone for coming today and spending an hour with us and talk about in-memory databases and tables, and I learned a lot. I hope everyone else did. and I hope you all have a great day. And by the way, Eric, I think you're going to come back later on in the year and give another topic. So thank you for doing that, you know.
Great.
All right, y'all have a great evening.
Everyone have a good day now.